Hello, my name is William Major, and I will be speaking with you today about methanol, CH3OH. Methyl alcohol, commonly known as methanol, is a commercial chemical solvent. It is a colorless liquid with a characteristic pungent odor. Methanol mixes easily with water and even occurs naturally in humans, animals, and plants. Those who work in the oil and gas industry frequently encounter methanol as a byproduct of refining processes. It is mainly used for dehydration, de-icing, and injected both continuously and intermediately. It prevents the formation of hydrates, mainly on offshore sources, and lowers the freezing point of water percentages during the oil and gas transport. Methanol is highly flammable and burns with a bright flame. It's barely visible in daylight, making it extremely dangerous. Its decomposition products are carbon dioxide, carbon monoxide, and formaldehyde. The primary route of entry for methanol is ingestion, although those affected can also be exposed through skin absorption, inhalation, and skin or eye contact. Keep in mind, these chemicals are most commonly ingested when eating in contaminated worksite or with contaminated fingers and hands. Once you're exposed, some of the symptoms may include irritation of the eyes, skin, upper respiratory system, headaches, drowsiness, dizziness, some vomiting or nauseation, visual disturbance or blindness, dermatitis. With the eyes, skin, and the respiratory system, the central nervous system and the GI tract are targeted more frequently. Those organs are targeted and affected by overexposure to methanol. Methanol poisoning can cause blindness and death. Most cases have occurred after ingestion. As previously stated, methanol poisoning after inhalation or skin absorption in the workplace has been reported. The lethal oil dose in humans is 2 to 8 ounces, or for the purposes of this course, 143 and 6,422 milligrams per kilogram. Now, according to the human study conducted and reported by the Centers for Disease Control, this dosage is equivalent to a 70 kilogram work of being exposed to about 7,000 to 225,000 parts per million for 30 minutes, assuming a breathing rate of 50 liters per minute and 100% absorption. The American Conference of Governmental Industrial Hygienists measures methanol's threshold limit values at 220 parts per million. Threshold limit values are widely used as measures of allowable exposure limits, which is why they were adopted into law as the permissible exposure limits in the OSHA Act. OSHA's permissible exposure limits for methanol is also 220 parts per million. The Centers for Disease Control, National Institute for Occupational Safety and Health measures methanol's recommended exposure level at 220 parts per million overall, but 250 parts per million for skin exposure. The permissible exposure limit is not a regulatory requirement. It is a recommended guideline for upper exposure limits to hazardous substances. According to the Health and Safety Guide distributed by the World Health Organization's International Program on Chemical Safety, the following measures of prevention and chemical care is required for methanol exposure. When immediate attention is needed, you must use thorough and vigorous washing of the skin with water. Gastric decontamination within 1 hour after ingestion. Keep the patient under observation if ingested. And contact urgently the nearest poisons information system. Surveillance advice. Control exposure by good working conditions and hygiene. Complete medical and occupational pre-employment history. Physical examination with particular attention to the skin, eyes, liver, and the kidneys. Identify pre-existing eye disease and folic acid deficiency and use as a baseline for future health assessments. Regular medical examinations should be performed in the event of excess exposure. Okay. Indoor air quality standards. Because carbon dioxide is a result of human metabolism, concentrations within a building often are used to indicate whether adequate fresh air is being supplied to the space. Typical carbon dioxide levels in urban settings range from 250 to 350 parts per million. According to OSHA standards, normal carbon dioxide levels max out about 1,000 parts per million. Occupied spaces with a good air exchange commonly see levels between 350 to 1,000 parts per million. The amount of carbon dioxide in the building is usually related to how much fresh air is being brought into that building. In general, the higher the concentration of carbon dioxide in the building, the lower the amount of fresh air exchange. On the flip side, analyzing levels of carbon dioxide in indoor air can reveal whether the heating, ventilation, and air conditioning (HVAC) systems are operating within standard guidelines. When indoor levels go above 1,000 parts per million, the effectiveness of the space HVAC system should be evaluated. Carbon dioxide at a very high concentration, greater than 5,000, can pose a health risk. Standard 62.1 and 62.2. Ventilation for acceptable indoor air quality. Founded in 1984, the American Society of Heating, Refrigerating, and Air Conditioning Engineers is a global professional association seeking to advance heating, ventilation, air conditioning, and refrigeration system design and construction. This standard was first published in 1973 as Standard 62. It specifies minimum ventilation rates and other measures intended to provide acceptable indoor air quality that minimize adverse health effects. It is intended for regulatory application to new buildings, additions, and changes to existing buildings, and to be used as a guide for the improvement of indoor air quality in existing buildings. This standard applies to all spaces intended for human occupancy, except those within single-family houses, multifamily structures of 3 stories or fewer above grade, vehicles, and aircraft. Ventilation requirements of this standard are based on chemical, physical, and biological contaminants that can affect air quality. Thank you very much.